Ba-da-ba-boy. My friends, let us begin part 2 of our video. Now, in the first video, we went over point slow form, kind of an introduction, but now we're actually going to hit it real nice, going over problems that we've done before, but maybe a little more advanced. All right, my friends, so let's go ahead and take a look at this. First, let's try to understand what the question is asking us. It says, determine the equation of the line tangent of f of x at 1, 1. Here's the equation. So here's the graph just for you to visually see. Determine the equation to the line. Well, the line tangent, remember, that means instant slope. What's the instantaneous slope at 1, 1? It would be something like this. But we don't just want to draw it. What we want to do is actually find the equation for this tangent line there, okay? So let me erase it because we're going to eventually get it. So we want to determine the equation. Well, we talked about this. We're going to need a slope and a point, and very nicely we have ourselves this point slope form. So anytime I see this equation in the vocabulary, I'll go ahead and write my equation. This is my point slope form, and I'll ask myself, first of all, do I have points that I can plug into this formula? Well, yeah, I want to plug in 1 and 1, right? X1 and Y1 are both 1, so let's just do that. Y minus 1 is equal to m x minus 1. So far what we got is pretty much halfway done. All that's left to do is find m, our instantaneous slope, our slope at that point. Well, we just need to take the derivative. So let's go ahead. I'm going to use a nice color. Let's go ahead and just do it over here. F of x is equal to 1 over x squared. I want to take the derivative of this, but notice that we have a division problem, and I don't like that. And we've been working with negative exponents now, so hopefully we're getting a little more comfortable. If I want to rewrite this, well, it's just 1 times, bring the x squared up above, but now it becomes negative, like such. Okay. Now we can go ahead and take the derivative of this function. Okay, multiply the negative 2 by the 1, bring it down, you get negative 2x to the, now subtract 1, which is negative 3. Okay, now that we have this derivative, this function, let's just go ahead and rewrite this. Now that because we don't know how to really work with negative exponents, right? So let's rewrite it. Well, let me ask this question. What does negative exponents mean again? Well, it means, right, if you have 3 squared, that means you're going to multiply 3. And if you have 3 to the negative 2, you're gonna 3 squared means you multiply on the numerator twice, right? 3 squared, 3 times 3. Well, 3 to the negative 2 means on the denominator you're going to be dividing by 2 3s, or 3 times 3, right? Which is 9. But you're dividing those 3 instead of over here. They're on the numerator. Over here, they're on the denominator. Well, notice the negative 2 is already on the denominator. So this is negative 2 divided by, bring this down, x to the third. Now we'll plug in. Well, this is just having the x value, so let's go ahead and plug in. Okay, 1, and we get negative 2, and we get 1 to the third, so we get negative 2 over 1, which is negative 2. So this is my slope, right? We have f prime of 1 is equal to negative 2. So let's go ahead and plug that back into my equation over here. And what we're going to get, my friends, is y is minus 1 is equal to negative 2 x minus 1. And there it is. We're done. On the AP exam, we don't need to show any more work. As long as we show this equation, we're 100% golden. Okay, and just for the purposes of this video, just for you to actually visually be able to graph this, let's convert this so you can visually see it graphed. All right, let's distribute the negative 2 across. We're going to get y minus 1 is equal to negative 2x plus 2, because negative 2 times negative 1 is 2. And now we're going to add 1 to both sides. And what we're going to get is y is equal to negative 2x plus 3. And if you graph this, you will see it will beautifully work out. Let's start with the y-intercept, negative 2. So you go down 2 over 1. There it is, down 2 over 1. And you're going to get the equation of the tangent line, this equation of the black line. All right, and that's it, my friends. You can see that this up here, really, they're all the same thing, right? This is just not simplifying. And to be honest with you, on the AP test, it doesn't matter. So don't even worry about simplifying it. Just you're good right here. This is the final answer and you're good to go. But for purposes of this video and you understanding what we're looking for, I wanted to simplify it through. So let's go ahead and do this. So we're going to do this for every problem down below. Finding the equation of the tangent line at the given functions. Well, we know this is asking us y minus y1 is equal to m x minus x1. And basically, now ask ourselves first, right? Because equation of the tangent line, well, we'll use point slope form. Do I have points to plug in? I do, 1 and 3. So y minus 3 is equal to mx minus 1. Okay, there it is. We just plugged in our points. All we need to find is our slope. So let's take our function and find the derivative. Well, we're going to get 5 times 2, right? Bring the 2 down over here. 5 times 2 divided by 2. X plus, oh, well, 1/2 is just a number. That's gone. So, okay, we're good. That's it. Well, what's going to happen to these 2's? Cancel. So we get dy dx is 5x. Okay. And let's plug in my x value. And we get dy dx is 5, right? Because 5 times 1 is 5. So we can plug this into here and we get y minus 3 is equal to 5x minus 1. And we are done. Nothing else for you to do. Again, on the AP test, they don't want you to simplify it. So we're good to go. This would be a final answer and you would be good to go. Now, there's no need to simplify this because, to be honest, we're not even visualizing it, but at least we know, right, visually, that if this is some quadratic function, what we did is we found some kind of equation, right? I don't know, some kind of, it's positive, so we know it's like that, but some kind of equation there at 1 where we know it's positive and we have this equation there and we have a visual representation maybe mentally. Okay. Let's take a look at B, because I think if you look at B, you'll notice something is very different about this problem. So if we write, well, let's write our point slope formula, because these problems are all the same. We want to find the equation to the line tangent of y. Well, do we have an x value? Well, we do. We have an x value, but what do you notice? We don't have a y value. Well, how can we find that y value? Well, here's the equation of the function, right? We just need to plug in -1 into our equation, and that'll give us our corresponding y value. So let's just go ahead and do that first. We'll plug in -1 to the 4th divided by 2 plus 3 times -1. -1 to the 4th, if you do that out, that's just 1/2 plus -3. Okay. So what we're going to get here is y is equal to -2.5. Okay, just, 1/2 plus -3, you get -2.5. So let me write it up here. I know now that when my x value is -1, my y value is -2.5. Now let's go ahead and plug this into my point slope formula so far. Well, we have y minus -2.5. We don't know what our slope is, and we get x minus -1. What's going to happen to these two negatives? Well, they're going to turn positive. Y plus 2.5 is equal to m. Negative turns positive plus 1. Okay, this is what we so far have. Now what's left to do is find our slope. So let's go ahead, take the derivative, and find that instant slope, and we're good to go. So dy dx, okay, we're going to bring the 4 down, so we get 4x to the 3rd by subtracting 1. Plus just 3, right? 3x, derivative of 3x is just 3. This simplifies down so that we get 2x to the 3rd plus 3. Plug in -1 into here. Dy dx is equal to 2 times -1 to the 3rd plus 3. -1 times -1 times -1 is still -1. So we get -2 plus 3, which is positive 1. So that is my slope, right? Dy dx at -1 is positive 1. So now that we know my slope, let's plug it into the equation. Y plus 2.5. Oh, let's write it up here. Y plus 2.5 is equal to 1 x plus 1. And that's it, my friends. That is exactly what you want to do, and it does not change. So with that being said, I think some of these you can go ahead and do if you wanted to. I think maybe the one that I'd like to put an emphasis on would be D, just because we have a square root, and I want to review those as much as possible. So this will be the last one, and we'll call it good. So we want to find the equation of the line tangent, right? That should be an indicator that we have to use our point slope formula, and we need to plug in the x value into our function to get our y value, because we don't have a y value. So we're going to get 3 times the square root of 4 minus 4. The square root of 4 is 2, so 3 times 2 minus 4. 3 times 2 is 6 minus 4 is 2. Okay, so I know when my x value is 4, my y value is 2. Now let's go ahead and plug these in very quickly into my formula. that we have here. And now, my friends, all that's left to do is find our slope. So we want to take the derivative of this function. So so let's just rewrite it first, right? We have a square root. Square means 2. Remember, we need to turn this to a fractional exponent. It's 3 times x to the 1/2. Okay, minus x. Now let's go ahead and take the derivative of this. Okay, well, let's bring the 1/2 down. So we're going to get 3 times 1 divided by 2. Okay, times x to the, let's subtract by 1, but let's do it in a fancy way, 2 over 2, so we get common denominators. 1 minus 2 is negative 1/2. And then what's the derivative of negative x? Well, this is like negative 1 times x, and remember, this is just going to leave you with the number in front, negative 1. Okay, well, if this fraction here is a little confusing to work with, you can always just put a 1 underneath and multiply across. 3 times 1 is 3. 1 times 2 is 2. We have 3 over 2 times x to the negative 1/2 minus 1. Okay, we still need to rewrite this because I don't like negative exponents. Now, remember, negative means you're going to put it on the denominator. Well, look over here. There's already a denominator down below. So let's just flip it and put it down below. We're going to get 3 over 2 x to the positive 1/2 minus 1. Okay, all we're doing is just putting it underneath because there's already a denominator. When the other problems we didn't, right? Something like that, we'd have to put it ourselves. Because there's already one there, we can just put it there. Okay, now let's go ahead and plug in 4, and I'll go ahead and do it over here. 3 over 2, 4 to the 1/2, okay, minus 1. Well, remember fractional exponents, right? This just means what two numbers multiply to give me 4, right? What two numbers multiply together to give me 4? Well, remember, this is just square root of 4, which is 2. So we're going to get 3 over 2 times 2 minus 1. 2 times 2 is 4, so we get 3 over 4 minus 1. Okay, now I'll rewrite this so we have common denominators. 3 minus 4 is minus 4 over 4. So I'm going to get negative 1/4, right? 3 minus 4 is negative 1/4. This is my slope, right? We had to do all that work just to get our slope. So we can finally conclude y minus 2 is equal to negative 1/4. And then x minus 4 on the outside. And that is the final example I wanted to go over. A little challenging, but I think this kind of shores up all the problems that we've done, kind of putting it all together with maybe this little added wrinkle, which is finding the equation of the line tangent. And you could see here, if you wanted to do this, this is kind of the same idea. Let the function be defined by this, which of the following is an equation of the line tangent at the point negative 1. Okay, and if you want to, you can go ahead and do this problem. I'll try to send over an answer key. All right, my friends, you guys take it easy, and I will see y'all soon.